I'm Cyriac. I am customer project manager working at SMA. I'm responsible for the technical interfaces with the customer for utility, scale, storage, and PV plants. We are seeing an immense potential and also interest from different developers and stakeholders in Philippines around the PV and storage domain. And I believe SMA is in a very good position to anchor into these beliefs and gain the confidence of the developers here, so we can engage with them at the project levels practically. The owners can secure their assets for 25 years through our extended warranty program, which means that kind of mitigates the risk what they are going to face with respect to technology changes that's going to happen in the next 10, 15, 20 years. In addition to that, the plant uptime, the SMA inverters, the way they are designed and operated are kind of optimized not just to secure the inverters uptime, but the plant's uptime. So the owners will always have higher yield when it comes to using the SMA technology. With respect to large scale PV and storage, the clear trend that is emerging is the long duration storage, wherein our AC coupled BESS solutions would fit in. And in addition to that, the utilities or the Escoms around the world, they don't prefer a kind of a PPA which is based on the bell curve of the solar. Rather, they want a firm power, and this is where the DC coupled solution with SMA kicks in and can support such PPAs. And in addition to that, we are also seeing the trend that is catching up is putting the grid forming capable inverters into the public grid that can, in addition to doing its baseline business case, can also contribute to the stability of the grid. Batteries kind of essentially stores the energy, but it is the inverters with its power electronics and the intelligence that has to, let's say, dance to the tunes of the grid and the grid codes in the region, and that kind of makes the inverter a critical interface between the energy reservoir and the grid. And that could be the one reason, and the other reason is, like, we see the energy density of the batteries is so huge. It's not like PV, and that's where we see the inverter should have the intelligence to safeguard the asset, as well as to offer the protection and the intelligence needed for the plant operator to safely operate the assets. That's where we see the inverter has a critical role in playing in the BESS systems. The large scale storage plants fitted with the inherent storage capabilities can already offer frequency and voltage stabilization characteristics to the grid in a way that it brings back the frequency when it is dropping, and doesn't let the frequency to drop below a certain threshold. And in addition to that, we see more and more grid forming capable inverters getting connected to the inverters, which can act or provide a response at the transient and subtransient time frames. So that will increase the stability of the grid by providing some inherent responses that is required during any kind of disturbances that originates on the grid side. So in the old school way of doing things, it's just the PV that is feeding into the grid, and then there is a revenue generation happening. But if you add storage based on a DC coupling or an AC coupling method, then there is an additional opportunity for the owners to participate in the ancillary services market or capacity market, or also participate in the spot exchanges through energy arbitrage opportunities. So these are the major trends or the revenue streams that we see the owners are able to cascade over and above their existing revenue streams.